the chapter 3 review number 1. Excuse my voice a little bit, just trying to get over a little bit of a cold, but I feel pretty good. So let's go over essentially reviewing sections 3.1, 3.2, and 3.3. All right, so these first ones are from 3.1. We're going to evaluate these quadratic functions at certain values for x. So we're going to plug in -3. Remember to use parentheses. If you need to use a calculator to help you with this, that's fine. I'm not testing, the ability to do like PEMDAS. But I'm going to just use my brain here. So -3 squared is 9, but the opposite of that is -9. -9 times -3 is a positive 27, and then bring down the +3. So -9 plus 27 is 18. 18 plus 3 is 21. So f of -3 is 21. Let's do it again. Different function, different input value. Let's plug in -5. So I'm going to do -5 squared. You always do the exponent first, right, before we do the multiplication. So -5 squared is 25. So plus a -5 is really just -5, but you could keep writing plus -5. 25 times 3 is 75. So 75 minus 5 is 70. 70 minus 8 is 62. So f of -5 is 62. So that's it for evaluating quadratics. These next two are also evaluating. One of them is a quadratic. Number 3 is a quadratic. But number 4 is an absolute value function. And we're going to evaluate these from their graphs. So essentially just remind yourself that this is the x value. So you zoom in, go to the x value of -8. Here it is. And find where the curve has a point at the x value -8. So it's -8 comma. The y value is 2, which I care about the y value. So f of -8 is positive 2. That's how you do that process. Let's try this one. This one says 7. So here's 7. There's the point, which is 7 comma 2. Oh, look at that. It ends up being the same thing. That's just a coincidence. They're not always going to be the same number. All right, so that's how you do it when you're given the graphs. All right, so that was the first unit, 3.1, or lesson. Let's do the next lesson, 3.2, which is talking about domain and range. All right, so I'm going to do domain and range for both of these. Remember, for domain, we're looking from essentially left to right, the lowest x to the highest x value. And range is kind of like bottom to top, the lowest y to the highest y value. So the domain, my farthest x value is right here at -6. My farthest to the right looks like it's here at +8. And you notice both of those are closed for those x values. So my domain is going to be -6 to +8. Now let's do the range. My lowest y value is here at -11, right? That same point. Now here's the tricky part. This point here, which I used for one of my points for the domain, is actually not going to be used for the range. My highest y value is up here at +8, right? And we are touching it, right? It does touch right there at +8. So my lowest y value was -11. It's closed, so I put a bracket. And then my highest y value is +8. We are touching it, so it's closed for another bracket. That's how you do those. Let's do domain and range for this one. All right, so again, the lowest x value is here at -9, the highest x value of 4. But notice this point is open, so I cannot include -9 on my domain. So I use a parentheses to show you that you almost get to -9, but you don't get to use it. And then going to 4, but this one is closed, so I get to use a bracket for 4. Now the lowest y value is right here at -1. And again, the highest y value is actually neither of our points. It's up at 9. So this is one of those where they're both going to be closed. We are touching both of those. And the lowest one is -1. Highest one is 9. And just a reminder, it's not always going to be about the points that are on there. Sometimes it will be, right? Like both the domains used it. But just be careful when you're doing these, that you ask yourself, is that the highest or lowest particular value. All right, let's do a piecewise function. I know this is probably going to be the toughest one for you guys. That's okay. So I'll show you real quick. I make t-charts for both of these pieces of the function. The first piece is the function x. The second piece is the function x minus 4. So I'm looking for values that are less than or equal to -1. So here's some values that are less than or equal to -1. And when I plug them in, since the function is just x, whatever you plug in is actually the y value. All right, so I'm going to plot those, which is essentially -1, -1, -2. So you can see that we have this going on forever. All right, just make sure you're careful on which direction you're drawing it. I'll get a lot of students that won't draw it the way that I'm drawing it. They'll draw it kind of up and to the right. But as we move past -1, we actually have a break before our next piece of the function. Notice I use a closed circle at -1, -1, right? I use a closed circle because of this or equal to line underneath. Now for the other piece, values that are greater than 2, so 3, 4, 5. But be careful here. I am going to plug in 2, but because it doesn't have the or equal to line, I will be using an open circle at 2, comma, we get here, 2 minus 4 is -2. Okay, so I'm going to plot those points, starting with 2, -2. That's going to be an open circle, then 3, -1, 4, 0, 5, 1. You get the idea here. And that is our piecewise function. So just take your time on this. I think you can do it if you remember the steps in the process of making the t-charts, finding your values to plug in, actually plugging them in. Don't forget, is it going to be closed circles, open circles? Don't forget to check all that, okay? All right, let's do 2 more and then we'll be done. For these last 2, we want to determine the intervals on which each function is increasing or decreasing. So with this one, you don't need to worry about using brackets or parentheses. You can just always use parentheses for increasing, decreasing, right? And essentially, you just want to look at what's happening to the y values as you go from left to right. So you'll notice reading this from left to right, I'm decreasing until -5. Then I am increasing from -5 until an x value of 0. Back to decreasing from 0 to 5. And then finally increasing from 5 and looks like all the way up and to the right forever. So just be careful with this. What can be confusing is you're looking at the y values to see if they're moving up or down, but when you write the intervals, you care about the x values. So I'm increasing, I'll use the same color, from -5 to 0, and then increasing from 5 to infinity. For the decreasing, I'll go back to my pink color. I'm decreasing from -infinity to -5, and then also decreasing from 0 to +5. All right, so that's the process. It's going to take a little time for your brain to get used to it, so make sure you're practicing the delta math link that's associated with these problems. Let's do one more. So we're decreasing to start out here. Make sure I use the same colors. Yes. So decreasing until, oh, wait, look at that. That's kind of like a little kind of way to trick you. We're still decreasing, actually, even if there's an inflection point there. So we're finally increasing at -3. So I'll switch colors at an x value of -3. That's when the y values start to go up. Another inflection point, still going up. Another inflection point. Oh, look at this. We are actually increasing for the entire way after that, all the way to the right. So if I write down my increasing and decreasing, my decreasing was from the beginning, so -infinity until -3, and then increasing ends up being from -3 until the far right forever, so +infinity. Again, the hardest part is you're looking at the y values to see if they're going up or down, but when you write the intervals, you ask yourself, what are the x values associated with those changes? All right, so that's why we focused essentially here On this one, the only time it changed was at -3. Okay? All right, good luck. Don't forget, there are infinite delta math problems. Even if you finished all the links for this, you can go back to 3.1, 3.2, 3.3 and take a look and see if you need any refreshers. Good luck.